Hey guys, today I'm going to show you how to find the pesky volume of revolution using integration, and at the end of the video I'll show you how to check your answer with calculator. So stay tuned. Let's look at this example. This is a graph. The equation for the graph is x is equals to y squared. Now first, before we find the volume, we need to understand what a volume of revolution is. A volume of revolution is when we take the graph and we revolve it about one of the axes. So in this video, I'm only going to be looking at the x-axis. So if we take the graph and revolve around the x-axis, then what we get is a three-dimensional shape, which looks something like this for this graph. So we take the graph, we revolve about the x-axis for 360 degrees, and then this is the shape that we get. And what we are trying to find is the volume of this shape that is formed after revolution about the x-axis. Now, how do we do that? The way to find it is by integration. So let's look at this example here. So let's say we want to find the volume of this area. If this area is revolved around the x-axis about 360 degrees about the x-axis. And so how to find it is by using this formula over here. The volume is equals to integration of pi y square dx with limits a to b. Now let me just break down what this means here. First thing to note is whether we are revolving about the x-axis or the y-axis. If the revolution is about the x-axis, then we integrate with respect to x, dx. If we are revolving about the y-axis, then the integration is with respect to y, so dy. So in this case, we are looking at x-axis, so dx. Another thing to take note of is the limits. So a to b are the limits. And here, if we are revolving about the x-axis, then we take the limits of the x-axis. If we are revolving about the y-axis, then we take the limits on the y-axis. So in this case, we are looking for this area here, and so we revolve around the x-axis, and we are going to take the limits of the x-axis. So here, this is the boundary that we are looking at. So this boundary, we have the limits 5 to 7. So this would be 5 to 7, and then pi y square dx. Now pi will always be there, and according to the law of integrations, any constant we can throw outside. So eventually we'll put pi outside, and we will leave it out until the final calculation. So here is y square. In this equation here is very simple, very straightforward. X is equals to y square, which also means y square equals to x. So all you got to do is substitute y square. So y square is equals to x. Now remember, here we are integrating with respect to x, which means that whatever the unknown in the equation has to be in terms of x. We cannot have y. So we are going to substitute y square in terms of x. Now this is a simple equation. Let's say we had y square minus 5. Y square minus 5 plus 4x, for example. So all you have to do is make y square the subject of the equation and get an equation in terms of x, and then substitute it into this place here. Let's look at this specific example. So if we want to find the volume that we get when we revolve this area about the x-axis, 360 degrees about the x-axis, then actually we are looking for this shape over here. We are trying to find the volume of this shape actually. So how do we do that? Just have to use the formula. So we apply the formula. Our limits are 5 to 7. So we put integration with limits 5 to 7 of pi y square dx. Remember, when it's a revolution about the x-axis, then we integrate with respect to x. And this will be equals to integration of pi. Now y square here y square is equals to x. Remember, we have to substitute the value of y square in terms of x because we are integrating with respect to x. So y square will be substituted with y square equals to x. So x. Then we get integration of pi x dx with limits of 5 to 7. And then we go on to take out pi because pi is a constant, so we can leave it outside. And then we go on to do the integration. Now, many students always forget this step. This is a common careless mistake, so don't forget to integrate before you substitute the limits inside. So when we integrate x, we get x squared over 2, then with the limits of 5 to 7. And so when we go on to solve, put 7, substitute x is equals to 7 first, so that's 7 square over 2 minus, substitute 5 inside, so 5 square over 2, and this will give us 12 pi. Now this is the more complicated one. What if we have a floating region? So the boundary is actually floating here. It is not at the x-axis, but we still revolve about the x-axis. So first let's look at what is the shape that comes out when we revolve this area here about the x-axis, 360 degrees about the x-axis. So actually when we revolve it, this is what we get. This is what we get in the end. So the center space here is empty. This is the space here. This is the space in the center. Now what we got to do here is, we cannot find this area separately. What we have to do is find the volume of the whole shape that is formed minus this empty space here. So this empty space in the middle minus the volume of the shape in the middle. Shape in the middle is actually just a cylinder. So volume of a cylinder will be the face area multiplied by the height. So in the cylinder, the face is a circle. The area of a circle is pi r square, and therefore the volume will be area times the height pi r square h, and this is h. Now how do we find r? So this is first the full area which we already did just now, which we know to be 12 pi. Now let's look at the volume of the cylinder. So how do I know this is 2? So this is purposely oriented this way to show you the comparison with the actual graph. So if you notice this here, the height, this one, is actually just here, 5 to 7. So 5 to 7 is 2 units. So this is 2 units here. And then the radius here is actually this line here. This line here, the length of this line here is 0.5 units. So the radius is 0.5, and this, the height is 2. And so the volume of the cylinder, which is pi r square h, we just substitute the values of r and h inside. So pi 0.5 square times 0.5 is the radius, 2 is the height, times 2. And we will get 0.5 pi. So 0.5 pi is the volume of the cylinder. So this volume of the cylinder is what we need to subtract from the total volume of this large shape here in order to get the volume that is asked in the question. How do we do that? Volume of the large shape minus the volume of the cylinder. We get 12 pi minus 0.5 pi, and so the volume is 11.5 pi. Now this is how we get the volume of a certain region that is not bound, where the boundary is not the axis itself. So we have to get the full volume and then subtract whatever volume is in the middle. So that's how you get the answer. Now I'm going to show you how to use your calculator to check. Now, of course, this I'm going to be showing you is a Casio FX 570 MS for this calculator. So what you got to do is, you can see beside the calc, there's actually the integration sign there. So press the integration sign, and then put in the equation that you want to integrate. So for ours, it was just x. Let's get back to that. So let's take this example. So we wanted to do integration of x with limits 5 to 7. So what I do is click on alpha and then click on x. So it's the close bracket here. This is x. So here, this is what you get, integration of x, and that's all for our equation. If there's something else, then you just key in the whole equation. Now the next thing you do is click the comma. The comma here is above the delete. Click comma and enter your lower limit first. So our lower limit here is 5. So I press 5, and then the next comma again, one more comma, and then the upper limit is 7 and close bracket. So integration of x with limits 5 to 7 will look like this. That's how it will look. And then you just press equals to, and here we got our answer, 12. So which is exactly what we found just now. 12, of course pi is outside, so it becomes 12 pi. And that is how you use the calculator to check your answer. Please remember to show complete workings, otherwise you will lose your marks. That's it for today, guys. If you've learned something, please hit the like. If you haven't subscribed, please subscribe. And if you want me to do more complicated questions, please comment and I will take a look at it. See you in the next video.